3, 2, 1, and liftoff of Discovery, hoisting harmony to the heavens.
Hello everyone, today we are taking a look at Rocket Lab's most recent booster catch attempts. Over the past few years, we have seen Rocket Lab continue to practice and work on the Electron launch vehicle. In addition, the company and its small lift launch vehicle have been responsible for tens of successful launches, along with over 100 satellites deployed. At the same time, Rocket Lab has been working to make Electron partially reusable. Most recently, Rocket Lab continued to test and practice catching the booster of Electron out of midair. These tests consist of dropping the booster from quite high over the ocean and proceeding to try and catch it while it's falling. This method is meant to not only save the company money each launch, but also speed up the process between launches, both of which are very important to the continued success of not only Electron's future, but Rocket Lab as well. This ambitious idea has some risks, but also well worth reward if successful. In recent tests, Rocket Lab has confirmed that they are consistently catching the booster. This means we are getting closer and closer to booster catch attempts happening each Electron launch. Here I will go more in depth into the process of catching Electron's booster, the most recent attempts, and the benefits in both time, money, and more. Over the past few days, Rocket Lab provided updates regarding their progress on catching Electron's booster out of the air. On January 21st, Rocket Lab CEO Peter Beck tweeted, "Doing rocket drop and helicopter catch test today. The team haven't missed one yet." This was tweeted alongside a photo highlighting one of the catch attempts and a helicopter grabbing onto the parachute. A few days later on the 24th, Rocket Lab tweeted, "On rocket fishing. The recovery team has been conducting drop and capture tests ahead of our first aerial rocket capture attempt this year. Can't wait to pluck Electron from the skies." This tweet also included a highlight video that was captured of some of the catch attempts during the day. This tweet also highlights some of the company's plans regarding Electron later this year. It looks as if Rocket Lab will attempt the first aerial rocket capture of Electron sometime in 2022. When it comes to ambitious ideas such as this one, practice makes perfect. We are likely to see more catch attempts as time goes on leading up to an official launch attempt. This process is quite complex and consists of multiple challenges, including tracking the booster accurately, lining up the helicopter, executing the catch, and more, just to name a few. Over the past few years, Rocket Lab has practiced catching Electron's booster out of the air. It seems they have gotten better and more confident over time as well. Rocket Lab didn't always plan to catch and reuse Electron's booster. Some of the first recovery methods included the deployment of an aerodynamic decelerator balloon to slow the booster, followed by the deployment of parafoil concluded by a touchdown in the ocean. After a successful touchdown in the ocean, the stage would be moved onto a ship for refurbishment and reflight. The most recent phases of Electron reuse involve using a parafoil and mid-air retrieval by a helicopter. After a successful mid-air retrieval, the helicopter would bring Electron to a ship that would bring the stage to the launch site for refurbishment and launch. Specifically, Electron's booster first deploys a balloon at supersonic speeds, which helps it slow down significantly. Once lower in the atmosphere and significantly slower, it will deploy a parafoil with a drag hook towards the back. The helicopter has a long line and hook which positions itself with the parachute and hooks onto it. This is the most complicated aspect of the catching process, as the helicopter will need to match the speed of the falling booster among other things. From here, the helicopter once hooked will gain control of the booster, which is no longer parachuting toward the ground. This process keeps the booster fully intact and avoids it coming into contact with any water at all. It's important to point out that this entire process happens over the ocean. The ship that the helicopter is initially staged at is positioned near the expected landing site of the booster. From here, the helicopter takes off and is ready to attempt a booster catch. Once caught, the helicopter flies back and carefully lands and releases the booster back on the ground. We now know exactly how Rocket Lab catches a booster and their recent progress, but this brings up the question of why go through the trouble of catching the booster in the first place. While there is a long list of reasons supporting Rocket Lab's decision, there are two main ideas I want to highlight. These ideas include the process of saving both time and money. Money and time are some of the most important considerations when looking at a rocket company. Rockets are extremely complex pieces of technology and engineering which contribute to their immense cost and time to develop, manufacture, test, and launch. Rocket Lab specifically points out that capturing and reflying Electron's first stage enables higher launch frequency without expanding production and lowers launch costs. Starting with the cost, it becomes obvious the benefits of catching Electron's booster. As I mentioned prior, the alternative that Rocket Lab is currently using involves letting the booster parachute and land in the ocean. As you can imagine, this event not only damages the booster physically upon impact, but also completely waterlogs it. Rocket Lab does its best to get to the booster as quickly as possible and reduce any damage from salt water, but there is only so much they can do. This costs a lot of additional money through the process, time, and physical booster condition. Here is obvious how catching that booster could save Rocket Lab a significant amount of money. This would allow the company to easily transport, refurbish, and reuse each booster after a launch. Propellant and refurbishment would become the primary costs to prepare a used booster. While this method involves flying a helicopter and landing it on a boat, Rocket Lab is already spending money on the current process of recovering the booster from the water. The other primary benefit has to do with saving time. This is considered by many as an even bigger benefit compared to saving money. A lot of time goes into the manufacturing and testing process of a rocket. This is no exception for the booster, which is a vital component. Catching the booster would mean Rocket Lab could refurbish a used booster in a fraction of the time it currently takes, and be ready to reuse it right away. In the long run, this could have a significant impact on Rocket Lab's launch capabilities for Electron. Conclusion. Throughout the space industry, we are seeing more and more companies work towards at least partial reusability. This process saves a lot of time and money, among other things. In the long run, it makes much more sense to do everything you can to reuse different stages of a rocket, rather than letting them go to waste. This exact process is currently being tested by Rocket Lab and their Electron booster. They have announced they are hoping to attempt their first real catch attempt later this year. We will have to wait and see how their progress continues and the impact it has on the space industry. Thank you very much for watching.